All right, so today we're going to look at a couple examples of how to solve genetics problems involving incomplete dominance. So for the next few days you'll be working on alternative inheritance patterns, starting with incomplete dominance. So we're going to jump to question 2 here and do a couple examples. Question 2 says, in snapdragons, big R produces red flower color, so you need to be homozygous dominant to have red flower color, and big R little r produces pink. So again, the key with incomplete dominance is the heterozygous condition doesn't produce a phenotype that expresses just the dominant allele. What we have now is a mixture of traits. Of the dominant and the recessive aren't completely dominant. The recessive, you get something in between. Before we said that with dominance, the law of dominance, you mix black paint with white paint, you get black paint. But with incomplete dominance, when you mix black paint with white paint, you get gray paint. You get something in between. Big R, little r is white, so homozygous recessive is going to produce a recessive phenotype. Additionally, big B produces broadleaf, so that's dominant. Big B, little b produces intermediate, so that's the incomplete dominance happening there. And then big B, little b produces narrow. Work at the genotypic and phenotypic ratios in the following crosses. So we're going to do 2D here first, pink with a white, and then we're going to do F, pink intermediate with red broad. So let's just open this up and go here. So pink, again, that's the incomplete dominance. So that's going to be big R, little r, and white is going to be little r, since that can only be expressed with a homozygous recessive individual. So you notice that this is a heterozygous individual, so we have one gene that's heterozygous, so we're going to get two possible gametes from there, and then this is homozygous recessive, so our N is going to be 0, no heterozygous genes there, and so there's going to be one possibility there. So now we know that our Punnett square is going to be 2 by 1, so I can just do that. Okay, so I just draw my Punnett square, 2 by 1, like this. Okay, and now we can just put the gametes of this parent here, big R and little r, like this. And then this parent here is only going to produce little r gametes, and here's what the Punnett square will look like at the beginning. Now all we have to do is just fill that in. All right, bring in one letter from the top and the side, and now here's what we should be getting in the next generation. The genotypic ratio. So again, we have one big R, little r, and one little r, little r. What's this individual here, big R, little r, going to look like? For the phenotypic ratio, it's going to be one pink, to one little r, again, that's going to be white, to one white. So a cross between a pink flower and a white flower. Again, flower color is expressed incompletely. In snapdragons, you should get 50% pink, 50% white in the offspring. Okay. If we jump to question 2F, here we've got a pink intermediate with a pink narrow. All right. So again, this is a intermediate, incomplete dominant, being produced in heterozygous individuals. But we're following two traits at the same time. Okay, so there's a little bit more going on here. So let's start with pink. If you're pink, you're going to be big R, little r. And if you're intermediate, in terms of the size of the leaf, you're going to be big B, little b. Again, pink is big R, little r, and a narrow leaf is going to be recessive, and so you have to be little b, little b. Now we have to figure out here what the heterozygous individuals genes are. So it's big R, little r, and big B, little b. So my N here is going to be 2, and that's going to be produce 4 possible gametes. Here, only the big R, little r is heterozygous, so there's 1, N is 1, so 2 to the 1 is going to give me 2. So now I know that my Punnett square is going to be 2 by 4. So let's just do that. Let's create my Punnett square here, like this. And that's going to be 2 by 4. And there we go. Okay. So now let's take the gametes of this individual. Again, we need an R and a B in every gamete. Every type of gene needs to be represented in the gamete. So I just need to find all the combinations of R's and B's here. So big R, big B, big R, little r, big B, and then little r, little b. For this individual here, there's only 2 possibilities. So we've got a big R, little b, and a little r, little b. Again, every gamete needs one allele from each of the genes so that the gamete has all the information it needs to pass on to the next generation. So now all we have to do is fill it in. So this is big R, big B, little b, big R, oops, that's not very good, big R, little b, and then big R, big B, little b. Again, just bringing letters down from the top and the side. And we've got big R, little b, Keep going here. Big R, big B, little b, big R, little b, and then little r. Hopefully you can kind of guess what I'm going to say before I say it. And then little r, little b. Okay? A little messy. So now we look at the genotypic ratios here. Okay? So how many big R, big B, little b's do we have? Well, let's put some check marks in here. So I've got one big R, big B, little b, and I don't see any more of those. So we've got one of those. And big R, little b, put a check mark there. Do I see any more of those? Nope. So we've got one of those. And then big R, big B, little b, so heterozygous for 2 genes. So that one's heterozygous for 2 genes. And so that's one there and one there. So there's 2 of those. And then big R, little b, we've got one there and one there. So we've got 2 of those. And little r, big B, little b, there's only one of those. And homozygous recessive for both traits, there's only one of those. Now normally you would have to write, each of these genotypes out with the ratio of numbers here, but just for sake of time we won't do that there. Okay, now we have to interpret this. Now the interesting thing about incomplete dominance questions is the phenotypic ratio is going to be the same as the genotypic ratio in terms of the numbers. So there will be, it'll be 1 to 1 to 2 to 2 to 1 to 1, the same as what it is for the genotypic ratio, except now you're going to have to actually tell me what these organisms are going to look like. Okay, so let's just use a different color here. Let's just use a pink color. So this individual here, big R, big B, little b, there's going to be one red, and big B, little b is intermediate. Oops, let's back that up and change that. Okay, let's try that again. One red, intermediate. Okay, so let's cross that off. And then we've got one big R, little b, and so that one's going to be one red, narrow. I'm not going to write out narrow. And then 2 of the individuals were heterozygous, right? So there's going to be 2 that were pink. Remember, big R is going to be expressed incompletely. Heterozygous conditions always are. So pink, and then they're going to be intermediate as well. And then we've got 2 individuals who are big R, little b. So again, that's 2 that are going to be pink. And then little b is going to be narrow. And then we've got 1 individual that is little r, big B, so that's going to be 1 white. I'm just going to write WH for white. And then big B, little b again is going to be intermediate. And we have 1 individual who's homozygous recessive for both traits, and they're going to be 1 white narrow. Okay. So the one red intermediate individual is going to be here. The one red narrow is going to be there. The two pink intermediate is going to be there and there. The two pink narrow are going to be here and here. The one white intermediate is there, and the one white narrow is going to be there. So hopefully that gives you a hand. Okay.